Let's see how you did with your review questions. So number 1 says find the following square roots exactly without using a calculator, giving your answers in the simplest form. So the first thing we want to do is look for perfect squares that are factors of your radicand, which is the number underneath your radical sign. So for 25, that is a perfect square itself because that's 5 times 5. So the square root of 25 is 5. The square root of 24, though, that can be broken down into 4 times 6. And we know that the square root of 4 is 2, and we cannot break down that square root of 6. For number 3, I'm going to kind of work on the bottom here so I don't run out of room. 20 can be broken down into 4 times 5. And we know the square root of 4 is 2. So we have 2 square root 5. For number 4, the square root of 200, that is 2 times 100. And we know the square root of 100 is 10. So we have 10 times the square root of 2. Oops, that doesn't quite look like a 10, but that is a 10 in front of my square root of 2 there. All right, for 2000, we're looking for a perfect square that goes into 2000. So we might have to do a little bit of a factor tree because I know that's 20 times 100. And that's 4 times 5. So I have the square root of 100, which is 10, and the square root of 4, which is 2. So I'm going to have 10 times 2, which is 20 out front. But I still have that square root of 5 as well. So it's going to be 20 times the square root of 5. For number 6, we can go ahead and use our division property backwards. So we can have the square root of 1 over the square root of 4. And we know the square root of 1 is 1, and the square root of 4 is 2. So number 6 is the same as 1/2. For number 7, we can go ahead and break that apart too. So the square root of 9 over the square root of 4. So the square root of 9 is 3, and the square root of 4 is 2. For number 8, let's go ahead and create that into a fraction. So we're going to go ahead and do 16/100 for that, and we'll break it apart. So the square root of 16 is 4, and the square root of 100 is 10. And if we want to reduce that, we can get our 2/5 as well. For number 9, we have 1 over 10. So we can do the square root of 1, which is 1 over the square root of 10. Generally, we don't want to leave it like that, but we do not know how to rationalize the denominator yet. So we're just going to leave that as 1 over the square root of 10. For the last one, though, we can go ahead and write that 1 over 100. And we do know how to take the square root of those. The square root of 1 is 1, and the square root of 100 is 10. So that last one is actually 1/10. All right, let's use a calculator to find the following square roots, round to 2 decimal places. So we're going to get some practice with rounding to the nearest hundredth as well. So the square root of 13, we should get 3.61 because we get 3.6055, so that does round to 3.61. The square root of 99 is 9.95. The square root of 123 is 11.09. The square root of 2 is 1.41. The square root of 2,000 is 44.72. The square root of 0.25 is 1/2, or 0.5. The square root of 1.35 is 1.16. The square root of 0.37 is 0.61. The square root of 0.7 is 0.84. And the square root of 0.01 is 0.10. Right, classify the following numbers as an integer, a rational number, or an irrational number. We've looked at these already. These are all from our previous examples between 1 and 2. We know that the square root of 25, if I were to look back on my last slide, is 0.5. So because it's a decimal that ends there, it's not an integer, but it is in fact a rational number. The square root of 1.35, so that was 1.161895004. That is an irrational number because there's no pattern or anything like that, so that is an irrational number. The square root of 20, again, that is an irrational number. The square root of 25 is 5, so that is an integer, which is also a rational number. And the square root of 100, again, that is 10, so that is an integer as well, which is a rational number. Number 4 here, place the following numbers in numerical order from lowest to highest. So I'm going to just quickly change them into decimals. So the square root of 6 divided by 2, that's about 1.2247. So I'm going to round that. The second one here, 61 divided by 50 is about 1.22, or it is 1.22. Square root of 1.5 is 1.22474. We're going to go ahead to check that first one too again. And the last one is about 1.2307. So I'm just going to go back and check my square root of 6 divided by 2 because I might have to add a couple of numbers on here. That's 1.224744871. And then my square root of 1.5. That's actually the exact same thing. All right, so place the following numbers in numerical order from lowest to greatest. The lowest is our 61 over 50 for sure. And then it's kind of tied between the square root of 6 over 2 and the square root of 1.5. And then our greatest one is definitely the 16 over 13. The last one, use the mark points on the number line and identify each proper fraction. So we'll start out with A. Since it is 2 out of 3 markings, because notice there's 1, 2, and 3. So it's in the second place, so it's 2/3. B is 1, because we have the 1 there. It's between 1 and 2. And there are 1, 2, 3, 4, 5. So 5 markings total, and it's on marking 4, so that's 1 4/5. C is between 2 and 3, so I'm going to put that whole number of 2 there. And there are 1, 2, 3, 4 markings, and it's on marking 1 of 4, so 2 1/4. And the last one is between 3 and 4, so we definitely have our whole number of 3 there. And let's count how many markings there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 markings total, and it is on marking 7 of 9. So we have 3 and 7/9 for D.